is I'm going to let you use this separate piece of paper or the paper you're using on the test tomorrow. So again, write all this work on a separate piece of paper. I'm going to have you in Math 1 turn the paper in after you're done to use it. For Math 1 Honors, you could document your work online to get credit. But again, I'm going to let you use this paper on the test tomorrow. So write this work on a separate piece of paper and write the 5 words to let me know that you watched this video from beginning to end. So here we go. Hopefully you have a separate piece of paper. Just write the work. Do not have to draw any of these symbols or write any of these words, just the work. So here we go. The first word is build. Build is the first word. Okay, the work I'd like you to show on this one is at least showing the 3 right here, represent 3 white boxes, 8 for 8 white boxes, and 13 for 13 of those boxes that I'm counting. You will need to count those boxes tomorrow. I am adding by 5, which makes it arithmetic. I want you to backtrack to that 0 term and subtract by 5. So that will give me 3 minus 5, which gives me -2. That is my y-intercept. I'd like you to get in the habit of writing equations down before you look at choices. So my first is my recursive equation, f of x equals f of x minus 1 plus 5, recursive. This one, f of x equals 5 times x minus 2. That is explicit using the 0 term. And then the next one is f of x equals 5 times x minus 1 plus that 3 right there. Again, write these down. Recursive, explicit using the 0 term, explicit using the first term. It will make identifying which of these is not the right choice. This is good. Recursive, explicit. This one also works. Remember, 5 times x, 5 times -1. That -5 and 3 give you 2. This one has you, since you found the 0 term already, just write the function at the 0 term equals -2. And then I want you to use one of these explicit equations to jump ahead to the 25th term. You never want to use recursive. Only if I was going to the very next step would I use recursive. Jumping ahead from the 3rd term to the 25th, explicit. So using this equation, plugging in x is 25 times that 5 gives me 125 minus that 2, which gives me the function at the 25th term is 123. Okay, next problem, here we go. Next one has you again given the first term, given the recursive pattern that you're doing, taking every term before it, timesing by 3. We want to make sure that you could take that 7 and keep timesing that by 3 to fill in these next 4 values. So 7 times that ratio number of 3 gives me 21, times that 3 gives me, let's see, 63, times 3 gives me 189, and then that times one more 3 gives me 567. Again, make sure you're not just stopping at 189. You want to give the full next 4 terms. A lot of people stop right there thinking 7 is one of the next 4 terms, but 7 is the first term. These are the next 4 terms. All right, the next 2 problems where you need to identify if they're arithmetic, linear, or geometric exponential. This first set is timesing by 2, makes that geometric curved line, never constant rate of change. These going up by 2 the same amount each time makes this arithmetic, linear, straight line going up by the constant rate every time. So that sequence is linear. The top one is not exponential. Then of course the next set, this one's asking for exponential. Timesing these by 2 automatically shows me it's geometric, which means it has no constant rate of change. It's going to keep increasing at a fast rate. This bottom one is adding by 2, which is arithmetic. So that is linear. For this problem asking for exponential, I want to use that top set of numbers. That is the exponential set, the exponential sequence, the exponential pattern. Curve line. All right, next problem. This one has you list what these terms are. First, second, third, fourth. Has you see what I'm adding by. I'm adding by 7s, adding by 7s, adding by 7s. That's my common difference number. Know that this is the first term. It tells you that. Even if that wasn't there, we assume you know that's the first term. Backtracking to the 0, taking this 1 minus 7. 1 minus 7 gives me negative 6. That is my 0 term. 1 is my first term. So the explicit equations I'm going to use to plug in 12. First one is that 7 times x plus the plus the f0 term minus 6. Or you could use that same 7 times x minus 1 plus 1 right there. The second word is reps. Repetitions, reps. All right, I'm going to plug in 12 into this first explicit equation right there, and I'll show you both how they work. F of 12 shows me that number I'm plugging in. This is where I'm doing the math. 7 times this 12 gives me 84. And then that 84 minus 6 gives me the function at the 12th term is 78. I could also use the second form here, shifting over to the first term instead. And that will work by showing again that same notation. The function at the 12th term equals 7. In parentheses, I'm going to put my 12 right there, minus 1, plus 1. Going to finish up this work right here. Gives me 11 inside there, plus 1. Gives me 77 plus 1. Or the function at the 12th term is 78. This one has you distribute and combine like terms to see which of these forms is equivalent to this explicit form. And know that to do this, the work I need you to show is you leaving that 6 alone, distributing 5 times x. 5 times negative 1 gives me 5x minus 5. That 6 and negative 5 give me positive 1. You got 5 negatives canceling away 5 of these positives, leaves you excess 1 positive left over. And you can see that is the same. That proves that even though this doesn't look the same as that, they are equal. They're equivalent. This one doesn't work because when I distribute that 5, I get 5x minus 5. I still have that 4. 4 minus 5 give me negative 1. More negatives than positives. 4 of these positives cancel out 4 of these negatives, leave me excess negative 1. That is not the same. The bottom one also is not equivalent. This gives me 7 plus 3x minus 3. And that 7 and minus 3 give me positive 4. That is not equivalent. Alright, for these matching ones, again, my classes, I would like you to do the math to get that common ratio number. This one's timesing everything by 2. That is the first term right there, second term, third and fourth. If we don't say anything, we assume you know that's the first term. Or I could write f of 1 equals 8. But that is the first term. Going to the left is doing the opposite. You're dividing by 2, but remember we show that as multiplying by the reciprocal of 2, timesing by a half. 8 times a half, 8 divided by 2 gives me 4. And what I'd like my classes to do is take the time to write this equation right here with that 0 term times r2 to the x power. Or you could write that as f of x equals the first term, 8, times r to the x minus 1 power. So again, either the 0 term times r to the x, or the first term f of 1 times r to the x minus 1. I would like you to write them and then look at your choices. So you could see this one is close. It's got the right f1 term and the right common ratio, but instead of x minus 1, it has x. That's no good. This one up here has the 0 term 4, but it has 2 raised to the x minus 1. That's not accurate. That one's no good. This one, the bottom right, has the common ratio number mixed up with the 0 term. Don't do that. You never put a term in the sequence as the base. Never. That means this one is the only good one of the bunch. 8 times 2 to the x minus 1 power. Alright, next set. Here we go. Simple interest. They want you to use this as a geometric function, where I'm going to use 400 as my 0 term, or how much money's in there before the day has even started. They want you to change this 3% to its term as an r that you could times by 400. So 3% written as 1.03. There's my 400. If I could on your paper have you put an 8 right here, because I'm already using this equation to evaluate, so show me this is the function at the 8th term, put an 8 in there, equals 400 times that 1.03 raised to the 8th power. And again, since I'm using this already, I want you to change that to an 8. If I had this to the x power, I could have just left that as the equation to use before I plug in numbers. But please write that as f of 8, because I'm evaluating this for the 8th term. That gives me 400 times 1.03 to the 8th. I show you how to use your calculator on that to type in your answer. And then I need you to round to the second decimal place. So that gives me 506.7080. I'm rounding to this term right here, the second term. I look at the number to the right of it. If that's 5 or more, that rounding number goes up by 1. So this function at the 8th term, please don't put 400 in there. Change that. That should be f of 8. I didn't plug in 400 here, so I'm not sure why I wrote that. But change that to be f of 8. Write this as f of 8 as well. Don't write 400 in there. This is f of 8. But f of 8, again, that's not 400, that's 8, equals $506.71. Okay, these two just have you identify the part of the equation. They want you to see that the number without a variable attached to it is the 0 term. That is the y-intercept. If I was to graph it, that would show me how many gallons up at the top as it's going downwards and it's draining. So that 875, that's the y-intercept, the 0 term. We're going to call it the initial number of gallons in the pond before we start draining it, or the 0 term, or how many gallons before we've started draining it, or the initial number of gallons. This one down here has you look at this equation and realize that the only term that matches this is the fact that this says the deposit fee is $300. That's what that is. These other ones are no good because they say the rent is $300 each month. That's not true. The number in front of X tells you how much you're spending each month. That is $1,100 each month. This one says the deposit fee is $1,100. That is not true. That number is in front of the X term. That's your rate of change. That's how much you're spending each month. The only good answer of these three is the deposit fee is $300, or the zero term is $300, or the y-intercept is $300, or before you've been in there for even a second, you've already spent $300. Okay, next. These have you find this equation in slope-intercept form. Know that this should be -1 right here if you want to change that. But these are going down by 2. These are going up by 10. To find that slope, I'm going to take the rate of change of my change in y over my change in x. These are my change in y going down by 2. My change in x going up by 10. I write that -2 over 10. That reduces down if I divide top and bottom by 2 to -1/5. That is my common difference number. That's the number for my slope. That's the number that goes in front of x. So -1/5 x. To illustrate to you how I find that y-intercept term, again to show you here, the second term I give you is 3 from this table. But going up or down now by single increments, I need you to understand that from 2 and 3, which is given to you, going down the column, you're subtracting by 1/5, subtracting by 1/5. Going up, the opposite, adding by 1/5, adding by 1/5. So this term beneath it would be 2 4/5. Above it, 3 1/5. One more up to the zero term, 3 2/5. If you write that as a fraction, I'll take it for full credit. If you change this equation to decimal form, I'll give you credit for that. This is y equals -0.2x plus 3.4. There you go. This one right here. Again, it has you find the common ratio. The third word is by. By. That is the third word. Okay, for this, show at least the fact that this 500 here given to you is the zero term. I want you to show me the numbers you're using to find this common ratio. I could divide 535 by the one before it to get 1.07. Show me how you're getting that common ratio number. I could have also got that 1.07 by dividing 572.45 by 535. Don't want to use these because they're jumping ahead to the 6th and 12th term. And again, in my classes, I want you to take the time to write these equations out before you look at your choices. This equation is the zero term 500 times r to the x power, or 1.07 to the x power. Or I could also use f of x equals the first term 535 times 1.07 raised to the x minus 1 power. And again, write these choices out before you look at the multiple choice questions. Here you could see it's close, but it has the wrong exponent up here. You would never write, you'd have just plain x right there. Be careful, it's close. This one underneath has the first term, but r to just the x. You wouldn't write it like that. You'd have to write it x minus 1. This one right here is someone making a mistake of thinking this is arithmetic and putting that number as your d number times x plus the zero term. Never do that for these percent problems. Geometric. This is the only good one. It has 500, the zero term, times r to the x power. So that one is golden right there. Okay, next problem. Here we go. This one has you find all the answers to this sequence. I want you to see that this is dividing by 2, but we write that as timesing by a half. Dividing by 2 is the same as timesing by the reciprocal of 2. That is the first term, second term, third, fourth. Going to the left to the 0 term, the opposite of timesing by a half is timesing by the reciprocal of that, which is 2. So 144 times 2, we'll backtrack to that 0 term, give me 288. That makes this geometric. The recursive pattern would be f of x equals f of x minus 1 times 1/2. And then the explicit form, I'm going to have you write one of them. I'm just going to list both. Is f of x equals always the 0 term, 288, times that common ratio number 1/2 raised to the x power. Or you could use f of x equals the first term, 144, times r 1/2 to the x minus 1 power. Either of those will work. I'm going to use the second one to evaluate it for the 10th term. So using the proper notation here, the function at the 8th term, show me what I'm plugging in, or the 10th term, I'm sorry. The function at the 10th term equals 144 times 1/2 to the 10 minus 1 power. I'm going to show the work up here. That gives me 144 times 1/2 to the 9th, realizing that's the whole fraction raised to the 9th power. That gives me 144 times 1 over 512. And I'm going to try to show you how I get that. 1/2 to the 9th power, you're timesing 9 of those 1/2s. So when I times straight across, 1 timesing each other just gives me 1. Timesing straight across on the bottom, 2 to the 9th gives me 1 on top over 512. That's where this comes from. I could put that 144, the whole number, over 1 and times straight across, which gives me f of 10 equals 144 over 512, equivalent to 288 over 1024, equivalent to reducing this down. So f of the 10th term, reducing this down on your calculator, reduces down to 9 over 32. And then that as a decimal is about 2.8. All right, next problem. This one is arithmetic. The fourth word is doing. That's the fourth word. All right, for this one, they want you to see that you're adding 13 to these. Adding 13, adding 13. So that means this is the first term, second, third, fourth. It takes adding 13 positives to this negative 67 to whittle it down to negative 54. Adding 13 more positives whittles it down to negative 41. Know that subtracting by 13 is the pattern going to the left. So negative 67 minus 13 gives you negative 80. This is an arithmetic sequence. The recursive pattern is f of x equals f of x minus 1 plus 13. The geometric, or the explicits for this one, give me f of x equals 13 times x plus the 0 term, negative 80. Or f of x equals 13 times x minus 1 minus 67. Both those will work if you plug in 10. So the function at the 10th term, plugging into this one right here, gives me 13 times 10. So the function at the 10th term is 13 times 10 minus 80. Gives me 130 minus 80, which gives me the function at the 10th term is 50. I could also use the second one here to get that same 50. If I was to evaluate this one for the 10th term, equal to 13, and then put that 10 right here, 10 minus 1, minus 67 gives me 13 times 9, minus 67, which gives me 117, minus 67, which also gives me 50. Okay, the fifth word is problems. At this point, Math 1, you are done with your practice test. There are no more problems. Take that paper, show me tomorrow for credit, and you'll get to use that and your other notes on your test. For Math 1 Honors, I have one more problem I'd like you to do, and I'm going to have you write a secret sixth word to make sure you really listen to me. And then tomorrow, show me that paper with that work on it and all 6 of those words, and I will let you use that paper on the test. If I see the work without the words, I won't let you use it. I want to see all this work and those 6 words on a separate piece of paper for me to let you use that in Math 1 Honors. So here we go, last problem. And the last 6th word. Okay, this one, finding the missing term. I need you to know that from 15 to 30, I need to add a D plus another D plus another D plus one more D, or the number of unknown common differences for this arithmetic sequence we're going to tell you is always one more than the number of empty boxes. I'm going to use these two numbers to set up my equation as 15 plus 5 of these D's together, written as 5D equals 30. I'm going to subtract 15 on both sides, and that gives me 5D equals 15. Divide both sides by 5, and that gives me D equals 3. And then use that D as 3 to fill in your table. Adding 3's, adding 3's, adding 3's. So plus 3, plus 3, plus 3, plus 3. Gives me 15 plus 3, 18, plus 3, 21, plus 3, 24, plus 3, 27, plus 3, 30, plus 3 more 33, plus 3 more 36. This one, the geometric one, you're not finding number of D's here, you're finding number of times R's. How many times R times another R times another R? There are always one more than the number of empty boxes, so that 1 times R to the 4th equals that 81. I'm going to divide both sides by 1. On tomorrow's test, you will be dividing out a number first. That gives me R to the 4th equals 81. And then I'm going to take what's called the 4th root, which is the inverse operation of something to the 4th power. Those will cancel away and just give me R equals 3, because 3 times itself 4 times gives you 81. In my classes, I showed you on the calculator how to do a 4th root, but that R number is 3. I want you to replace that R with the 3 that it is. Fill in that table. Make sure you go to the left here. I'm not sure if I filled that left term. I'll tell you what that is, but timesing 3, timesing 3, timesing 3 gives me 1 times 3, 3, times 3, 27, times 3, 81. Times 3 more, 243, times 3 more, gives me 729. Make sure you don't leave this blank one like I did. Going backwards, you're dividing by 3 or timesing by 1/3. So 1 times 1/3, this will be 1/3. Make sure you go backwards too. 1/3 would fill in that 0 term. All right, the last word is study. That is the 6th secret word, is study. So again, my math honors classes, if you have all this work and those 6 words, I'll let you use that paper on the test tomorrow. Anything less, I will not let you use it. Good luck.